So guys, welcome to our channel once again. In today's video on our WAEC Physics Exam Revision Series, we have here these 10 WAEC repeated questions to answer on the topic Structure of the Atom. So let's go ahead and start with the first question here. It says, the electrons in a cathode ray tube are produced by A. Applying a magnetic field to the Y plates, B. Applying an electric field to the X plates, C. Ionization of the air, D. Heating filaments. So guys, the answer to this question is option D. The electrons in a cathode ray tube are produced by heating elements. And that's it for this question. Let's go ahead and consider the next question, guys. So guys, here the next question we have here is question number 2. It says, a photon of wavelength lambda naught is emitted when an electron in an atom makes a transition from a level of energy 2ek to that of energy ek. If the electron transits from 4/3 ek to ek level, determine the wavelength of the photon that will be emitted. Alright, so guys, let's see. For the first time, we have ek, 2ek to ek. So it transitions from 2ek to ek to make the wavelength of lambda naught. So in that case, 2ek minus ek is equal to lambda naught. And 2ek minus ek is actually ek. So ek is equal to lambda naught. So in that case, lambda naught is equal to ek. But then again, it says here, if the electron transits from 4/3 ek to ek, determine the wavelength of the photon that will be emitted. So let's call that wavelength x. So in this case, 4/3 ek minus ek is equal to x. So if we subtract ek from 4/3 ek, we are going to have ek over 3. So in this case, ek over 3 is equal to x. So let's recall that ek is equal to lambda. So we can replace the ek here with lambda. In that case, it becomes lambda over 3 is equal to x. So in this case, x is equal to 1/3 lambda. And that's it for this question. Option D is the answer to this question. So let's go ahead and consider the next question, guys. So the next question we have here is question number 3. It says, when an electron jumps directly from an orbit of n equals 4 to n equals 2, A. Photon is absorbed. B. A photon is emitted. C. 2 photons are emitted. D. 2 photons are absorbed. So guys, the answer to this question here is option B. A photon is emitted. And that's it for this question. Option B is the answer to this question. So let's go ahead and consider the next question, guys. Alright, so guys, the next question here is question number 4. It says, calculate the energy carried by an X-ray of wavelength 6.0 times 10 to the power of negative 10 meter. Planck's constant is given as 6.6 times 10 to the power of negative 34 joules seconds, and velocity is given to be, the velocity of light is given to be 3 times 10 to the power of 8. So guys, let's note that the energy here is going to be hc over lambda, where h is the Planck constant, c is the velocity of light, and then lambda is the wavelength. So if we plug in these values here, we're going to have 6.6 times 10 to the power of negative 34 times 3 times 10 to the power of 8 all over 6.0 to the times 10 to the power of negative 10. So guys, we'll calculate this out. You're going to have 3.3 times 10 to the power of negative 16 joules. And that's option D here, guys. So let's go ahead and consider the next question. Alright, so guys, the next question here is question number 5. It says, a metal with a work function of 3 electron volts is irradiated with ultraviolet light of energy 4 electron volts the kinetic energy of the ejection electron is, okay guys, so we can just sort this out by having 4 electron volts minus 3 electron volts, and that's 1 electron volt. So option B is the answer to this question. Let's go ahead and consider the next question, guys. And that's question number 6 here. It says, light of energy 5 electron volts falls on a metal of working function 3 electron volts, and electrons are emitted. Determine the stopping potential. So guys, here too, for us to determine the stopping potential here, we're just going to subtract the 3 electron volts here from the 5 electron volts here. So when we have 5 minus 3 electron volts, that's 2 electron volts, and that's option A here, guys. So let's go ahead and consider the next question. So the next question we have here is question number 7. It says here, beta particles are fast moving: A, photons; B, protons; C, neutrons; D, electrons. So guys, the answer to this question is option D here, electrons. Let's go ahead and consider the next question, guys. So the next question we have here is question number 8. It says, a metal has a working function of 4.375 electron volts. Calculate its threshold frequency. Alright, so guys, in order to calculate the frequency, we are going to relate to this equation. W, which is the work, is equal to H F naught. So F naught is the frequency here, the threshold frequency, and H is the Planck's constant. So guys, the W we have here given to us is 4.375 electron volts, which is actually 4.375 times 1.6 times 10 to the power of negative 13 joules. And that's because 1 electron volt is actually 1.6 times 10 to the power of negative 19 joules. So in this case, if we plug in the values for the variables we have here, we're going to have that 4.375 times 1.6 times 10 to the power of negative 19 is equal to 6.6 times 10 to the power of negative 34 times F naught. So guys, in order for us to find F naught, we'll make it the subject of this equation, and then we're going to have 4.375 times 1.6 times 10 to the power of negative 19 over 6.6 times 10 to the power of negative 34. So that's equal to 1.06 times 10 to the power of 15 hertz. And that's option B here, guys. So let's go ahead and consider the next question. So guys, the next question we have here, we have N is equal to alpha, and that's a value of 0.0 electron volts. Then E is equal to 3, and that's a value of 1.6 electron volts, and it goes on and on this way. And it says here the energy level in the mercury atom is illustrated in the diagram above. Calculate the ionization energy of the atom. So guys, the ionization energy here will be the energy required to remove an electron from the ground state. So that will be the absolute value of the ground state energy level here, guys. So the absolute value of the ground state energy level here, which is this negative 10.4 electron volts, will be positive 10.4 electron volts, and that's option D here. So that's it for this question. Let's go ahead and consider the next question, guys. So guys, the next and the last question we have here is question number 10. It says, both X-rays and gamma rays I can be produced by thermionic emission. II have low frequencies. III have short wavelengths. So guys, here both gamma ray and X-rays actually have short wavelengths, and that's option III here. So that corresponds to option D. So that's it for this question. And guys, this is where we'll end this video for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question in the comment section below, and we'll ensure to give you a response. So finally, guys, we want to encourage you to join our YouTube channel community, where we'll post major updates on WAEC examinations. So you can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.